In example 1, we're going to use substitution to solve the system where we have the two equations 2x minus y equals 1 and x plus y equals 5. Personally, I like to number my equations. Excuse me. So I know what I'm doing. I have equation 1 and equation 2. I like to look for variables with a coefficient of 1. We actually have 3 of those here, so you can pick anything you want, really. I'm going to start with solving for equation 2. I'm going to solve for, let's solve for y. I get y equals 5 minus x. We're going to substitute this in to equation 1. So I get 2x minus 5 minus x equals 1. This gives me 2x minus 5 plus x equals 1. And then I get 3x. 3x equals 1 plus 5, so I get 3x equals 6. X equals 2. I can now take that value and substitute it into either equation. Doesn't really matter. I'll go ahead and just plug it into equation 2. So I get 2 plus y equals 5, which means that y equals 3. Thus, my final answer is the ordered pair 2, 3. That is the point where these two lines are going to intersect. And that's my solution. Let's try one more example. I want you to use substitution to solve for this system of equations. We have negative 2x plus 6y equals 6, and x plus 3 equals 3y. If you want to, try this on your own first and then resume the video. Otherwise, you can just work it along with me. I have equation 1 and equation 2. I notice that here I have a coefficient of 1. So I'm going to start with equation 2 and solve for x. We get x equals 3y minus 3. I'm going to substitute this into equation 1, which gives me negative 2 times 3y minus 3 plus 6y equals 6. Distribute your negative 2. You get negative 6y plus 6 plus 6y equals 6. Negative 6y and 6y cancel, leaving me with 6 equals 6, which is a true statement. This means we're dealing with consistent dependent solution of infinitely many solutions. To write my solution then, I want to either solve for x or y. I've already solved for x. Ordered pairs are usually written x comma y. So instead of an x, I'm going to put in 3y minus y comma y. And this ordered pair is going to work for any real number y. And that is my set of possible solutions. You could have also written everything in terms of x if you wanted to. We could have solved for y and seen that in equation 2, y equals x plus 3 all over 3. Meaning that in x comma y we could rewrite this as x comma x plus 3 over 3 such that x is a real number. And that's another way to write our solution set. Either way works, but we do like to write it in terms of a single variable, or at least as few variables as possible. Okay, next we're going to talk about elimination.